Today's video here is a nice problem. It's coming from the Polish Mathematical Olympiad edition 2003. Here is the following question. Decide whether there exists a prime p and non-negative integers x, y, and z such that we have this following equation. We have this product, which is 12x plus number 5 is multiplied by 12y plus number 7 equals prime to the z. Okay, so which means we have a power of p for the left hand side of this equation. So when you see the equation comes like this, expect you are not going to find a solution for this equation. Okay, even though we should work out to see why this equation doesn't have a solution. Okay, you can give the try to this problem pre get to the solution. Go ahead, pause this video when you want to come back to see the full solution. Okay, now let's go through this one. Before I proceed with the solution, I would like to explain this one a little bit. Since we have a prime number and we have the combination linear for these two expressions, we have x and y are the unknown variables here. It's hard to find those values since we have two different variables. Okay, if you have the same variable, it will be easier to solve, but now we have two different variables here. So we are going through the GCD. Since we have a prime here, so this term must be divisible by p, and this one must be divisible by p as well. Okay, so since this one is a prime, the prime has two options. You can have GCD equals 1 or GCD equals p. Okay, you can put the whole power of this product is going towards one term. If you have big exponent here, the other term it would be 1. That's what. Okay, or you can have both of them, it will be divisible by p. So the first thing we should know about a prime number, so as we know, the prime number could be even, it could be odd. Okay, GCD of these two terms, 12x plus number 5 and 12y plus number 7 equals 1 or p, since we have a prime here. Okay, but remember we have the combination linear here. Since we have 12x plus number 5 and 12y plus number 7 are odd, which means p must be odd. We cannot have p as an even prime while we have this product is an odd. This one is an odd, this one, because this one has to be the same since we have the power of p here. Okay, if this one is an even, if this prime is an even, this product must be even as well. This one must be even, this one must be even. The only difference here is the exponent. They will differ in exponent only. Okay, another thing here, let's calculate this difference. Since we have a combination linear here between these two terms, I got 12y plus number 7 minus 12x plus number 5. So I get here 12 is multiplied by x minus y plus number 2. Okay, by taking number 2 as a common factor here, I get 2 is multiplied by 6x minus number 1. 6 is multiplied by x minus number 1 plus number 1 equals t is multiplied by capital A. Okay, this one is telling us GCD of these two terms, 12x plus number 5 and 12y plus number 7 divides to capital A. Okay, this one is telling us GCD of these two terms must be equals 2. Okay, but remember here we have GCD for this one equals 1 and or p. This one it's clearly it's a contradiction. Okay, what we have contradict, we have contradicted GCD. This one, this GCD equals 2 and the GCD of this one equals 1 or p, which is impossible, which means we have no solutions for this equation. Okay, this is very quick method. Let's move forward to show this one in different ways. Without loss of generality, assume x is strictly inferior than y. Okay, so in fact we can put x is inferior to y, but x cannot equal to y, because if x equals y, I get here 12x plus 5 is multiplied by 12x plus 7. Okay, equals p to the z. Okay, So we have this term is the same as this term, but this term is different than this term. Okay, since p is a prime, which means is a power of p, the left hand side of this equation is a power of as well. So every term here will be differ by 2. Okay, so which means I have a factorization prime. So we'll have here p1 is multiplied by p2 equals p to this, which is impossible. Okay, this one cannot be factorization prime because we have to keep the same prime here, which they differ only in the exponent. Okay, not in the prime itself, because they must have the same prime here. So which means we are going to keep our inequality straight. Okay, so we have the left hand side of this equation is a power of p, while we have a right hand side of this equation is a power of p. Okay, so I'm going to transfer this one into the equation system. So I get here 12x plus number 5 equals p to the n. I get also 12y plus number 7 equals p to the n. Since x strictly inferior than y, which means n must be strictly superior than n 2. Okay, so I'm going to make the difference of two equations. Put in this one minus this one, I get here 12. I get 1 minus x here plus number 2 here. Then taking number 2 as a common factor here, I get here 6 is multiplied by y minus x plus number 1 equals, then making the difference of these two terms, I get here p to the m minus p to the n. Since p to the n is smaller than p to the m, since p to the n is smaller than p to the m, I'm going to take it as a common factor. We'll get p to the n factor p to the m minus n minus number 1. Okay, so previously we have proven p must be odd prime, cannot be even prime. Okay, so we already saw that, right? So p, since p is odd, and we have this term also is odd, this one is even, while p is odd. This one is odd. Okay, so since this one is even, is going straight to number 2 here. So I get p to the m minus n minus number 1 equals 2. In the other word, p to the m minus n equals 3. This one is starting as m minus n equals 1. Okay, the exponent. So in this case, m must be bigger than n, because the difference of this one is given as positive number. Okay, and also this one must be equals to p to the n. So I get here 6 is multiplied by y minus x plus number 1 equals p to the n, which is 3 to the n. Okay, and I have another two equations here. Plug in p into this one, I get here 12x plus number 5 equals 3 to the n. Okay, and I got 12y plus number 7 plus number 7 equals 3 to the m. Since we have this equation equals to this equation, I'm going to combine them together. So I get here 6 is multiplied by y minus x plus number 1 equals 12x plus number 5 equals 3 to the n. Okay, solving this equation, I get here 6y minus 6x plus number 1 equals 12x plus number 5. Bringing x term to the left and move over number 1 to the right, I get 6y minus 6x minus 12x, which is minus 18x, equals 5 minus number 1, which equals 4. Okay, dividing both sides by number 2 and taking number 3 as a common factor, I get here 3 is multiplied by y minus 3x equals number 2. Okay, reducing this one to mod 3, I get here 2 is a congruent to 0 mod 3. Okay, this one is starting as 3 divides number 2. It's clearly it's a contradiction. Okay, impossible. Okay, now we have a contradiction on this one. If you work in the inverse direction, you will find the same thing. You will find the contradiction. You guys, you can take that case. Okay, you will find the impossible at the end. So we have ended this video. If you have any question, just put it in the comment section below. By the way, don't forget to hit the subscribe button and support the channel. Thank you for watching and enjoy the rest of your day. Bye.